Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 176. Please turn to it. Page number 176, and today is our lesson number 17. Today we are just going to do one problem only because it's a very special problem, and I'll tell you at the very end why it is special. It is problem number 52. Problem number 52. We are told that pentagon has 5 diagonals. We are told that pentagon has 5 diagonals, which is not a surprise to us. Of course, pentagon has a 5 diagonal. If you draw a 5-sided picture, let's see if I can do a decent job of drawing. There is a 5-sided picture here, and if you were to draw the diagonal, there will be 5 of them. There is one right here. There is another one right here. There is one more, 3. There is 4, and what did I miss? And 5. There you go. There are 5 diagonals in it. So that was not a surprise. The question is how many diagonals does an octagon have? Now this is where you have to be a little bit careful. You have to realize where you are in the exam. We are on number 52. This is not supposed to be an easy question. So if your first instinct is to simply go, well, if 5-sided picture has 5 diagonals, then obviously 8-sided picture is going to have 8 diagonals. And if you feel that you're done in 2 seconds with the problem, stop and ask yourself. Ask yourself, if it were that easy, if the question were that easy, why would it be number 52? Why would it be labeled as number 52? Obviously there is something more going on here. Let's do a proper job of it, alright? Of course, answer choice 8 is going to be one of the answer choices, and there's a technical term for it. It's called the sucker's answer. Let's do a proper job of it, shall we? Let's draw an octagon, see what it actually looks like first. So here's our octagon. 1, 2, 3, 4, 5, 6, 7, and 8. I'm going to redraw it so that this line is about the same length as that line, so it looks a little bit better. There, just a little bit better. The very first thing we're going to do is we're going to christen all the vertices. Let's christen all the vertices. And of course we know what vertices are. Vertices is the plural of vertex. Vertex, of course, it's a very fancy way of saying a corner in the picture. So let's christen them, all of them. Starting from here, we're going to go clockwise. A, B, C, D, E, F, G, and H. There is a nice looking octagon, even though I say so myself. Now we're going to list the diagonal. Let's enumerate all the diagonals. So we're going to start from the very top so that we can have the room. We're going to enumerate, we're going to make a list of all the diagonals. What does christen mean? We learned the word christen a long time ago, if you recall, from the vocabulary videos. On day number 63, I believe it was, if I'm not mistaken. And if it turns out to be day 63, then that will be an incontrovertible proof that some of us need a life. Oh my God, it is day 63. Oh Jesus. Vocabulary, day 63. Just type in ACT vocabulary words, day 63, and you will learn the word christen. Christen has 2 meanings. It has a literal meaning and it has a metaphorical meaning. Literally, of course, it means to baptize someone in Christianity. That's the literal meaning. Metaphorically, it simply means to give something or somebody a name. So we just christen all the vertices. You understand? I'm looking for something. What am I looking for here? I'm looking for a pencil. I'm looking for pencil because I want to put down a word that I just used in my list here so we can cover it in the future. incontrovertible, I said. I do not know how to spell it, so I'm not going to put it on the blackboard. The word is incontrovertible. What does it mean? An incontrovertible proof. Incontrovertible means something cannot be disputed, something that cannot be questioned. What I said is, let me use the word in the context one more time so you can hear it being used in the context. What I said is that as I was looking for the word christen in my list here, I said it was probably day 63 when we covered it, and what I said is that if it happens to be, actually, if it turns out that it was something that we covered on day 63 of the vocabulary word, that will be an incontrovertible proof that some of us need a life. Person who should remain nameless, you understand? Anyway, let's continue here. Enough of the silliness. Let's enumerate all of them. Let's enumerate all of them. Are diagonals. And I do not believe we ever learned the word enumerate. I'm going to make a list of that as well. Do you know what it means to enumerate? Enumerate is just a very fancy way of saying make a list. Make a list. If someone says enumerate them, they're telling you to list them. So that's what we're going to do. We're going to enumerate them. So let's begin our story, okay? And just because we happen to have the flair for the dramatics, just because I happen to have the flair for the dramatics, and because it just so happens I happen to be a proud owner of 4 different colors of markers, I'm going to flaunt them. We're going to use 3 or 4 different colors to do our diagonals. Actually, I have 5 different colors if I count the black one. So let's get going. Enough of the talk here. So let's begin with A. Let's begin with A. Obviously, when we're talking about diagonal, okay, listen carefully. Listen very carefully. When we're talking about a diagonal from a given point, we're going to start our story obviously A because it's only logical. When we talk about a diagonal from a given point, the 2 neighboring points do not count. A to B is not a diagonal, and A to H is not a diagonal. Those are the sides of the octagon. So the story is going to begin with AC. AC. Oh, this blue is moribund. It's dying. Well, not to worry. I happen to be a proud owner of another blue marker. Then we have AD. Voila. Then we're going to have AE, AF, AG, and finally, well, that's it. AG is where the story is going to end, because it's not going to go all the way up to AH. I was about to write AH, but I just told you AH is not a diagonal. So here we go. AE, AF, AG. Okay, keep watching. There is a payoff at the end. Let's learn that word as well. I'm going to put down, these are good vocabulary words to know. What's a payoff? Do you know what a payoff is? What I said just now is that there's a payoff at the end. Payoff. What does it mean when someone says there is a payoff at the end? Payoff is just another way of saying a reward. There's a reward at the end. You just have to be patient. Do you understand? If somebody's telling you the story and if somebody tells the joke, and the joke at the very end when the punchline comes, well, that punchline is your payoff. Do you understand? That's why you sat there patiently listening to the joke, because you're waiting for the punchline. That's your payoff. That's your reward. Do you understand? Very good. So there is a payoff. Just be patient. Let's use the red one now. Now we're going to do with B. So we're going to start our story with B. Again, when we're dealing with B, when we're dealing with point B, the 2 neighboring points do not count as the diagonals. So BC will not count as a diagonal, neither would BA. So the story will go from BD. BD, BE, BF, BG, and BH. That's it. So BD, if I can find a decent red marker. Just give me one brief second. I'm sorry. Just give me one brief second. I am still here somewhere on the planet. Aha! What do you know? I found a brand new one. I'm going to open it. It's got a red, a blue, and a green. What do you know? Now that is the weirdest looking red one I have ever seen. It's more like a pink one, which is quite alright as long as by virtue of using it I do not begin to question my virility. Do you understand? Should we learn that word virility in the future? Let's learn it. And virtue, we learned it long time ago. Virtue and vice. But the word virtue, the way I used it just now, it's a different meaning. Learn this word. It does not. I know you are here for the math part. You are not here for vocabulary. But you should not have that kind of attitude. It is always a good idea to improve your vocabulary. Virtue and vice, I do not know when we learned them. Day number 7. Day 7. Just type in vocabulary words, ACT vocabulary words. Day 7, and you will learn this word virtue and vice, and you will learn the meaning of the word virtue in the context that I just used. I'm not going to keep going because otherwise we'll never get anywhere. Okay? Let's go in. BD, BE, BF, BG, and this time it's going to go up to BH. B to H. I'm going to redo them. This is a nice color. BD, BE, BF, BG, and BH. That's Pakistan. Aha. I'm telling you. Oh no, let's move on then. Let's carry on. We have the blue, we have this one. Let's do the green. Now we're going to start with point C. Again, when we start with point C, the two neighboring points are not going to count. We're not going to count B and we're not going to count D. The story is going to go from BE. Well, you see, okay, listen carefully. Story is going to start from BE. Why not BA? Because BA, why not CA? Because CA is already taken care of. When we do AC, the diagonal AC is same as the diagonal CA. We cannot double count it. Do you understand? Repetition is not allowed. Similarly, we cannot talk about, so the CA does not count, CB does not count, CD does not count. The story is going to start from CE. So here's your CE. CE, CF, CG, CH, and that's it. CA will not count. So CE, CF, CG, and CH. So far so good. Now let's do D, letter D. I'm rapidly running out of color here. Let's do orange, shall we? We haven't done orange. We can do letter D. D, again, from D right here. We're not going to talk about DA because DA is same as AD. We're not going to talk about DB because DB is same as BD. We already done that. Similarly, CD is not going to count because it's just a side. DE is not going to count because it's just the side of one of the sides of the octagon. The story is going to begin with DF. The story is going to begin with DF. DF, DG, DH, and that's it. DF. The story is going to begin with DF. It's to be lower. DF, DG, and DH. That's it. Now let's do letter E. Let's do letter E. Do I have any other colors? Blue, green. Let's do black one. Letter E. So letter E, again, when we talk about letter E, listen carefully. Of course, I understand that in a real exam, you probably will not have an hour and a half to do one question. Do you understand that? I realize that. I'm fully cognizant of it. We are here for learning purpose. We're just having fun. Do you understand? Don't be in a rush. Just do it in a leisurely way, and don't turn it into a chore. Okay? Listen. So we're looking at E. Again, when we talk about point E, EA does not count because it's already taken care of. When we talk about AE, EB does not count because we have BE. EC does not count because we have CE. ED is one side of the octagon, that doesn't count. EF is not going to count. EG is where the story begins. EG and EH. EG and EH. And finally, the last point, which is F, which is point F. And I'm desperately looking for one cool looking color, if I can find it anywhere. No, I do not have any more color, and I don't want to use the same color that I've usually used. This is a dilemma here. This is a real agony. What should we do? What color can we use again? Oh boy, I know the video is running and so forth, but okay, let's do the blue one again, which is point F. And again, the only thing that is left in F is, again one more time, FA is not going to count, we already did that. AF, BF is taken care of, CF is taken care of, DF is taken care of, EF is side, EG is side, and FG is side. The only thing that counts is F to J, F to H. F to H, that's it. F to H. I'm going to put it in a little bit different way so that we can see that this blue does not belong with the other blue. This blue does not belong with other blues. Do you understand? That's it. EH. That's it, we're done. That's it. All we have to do is add them up and that'll be our answer. And let's see what we get. So here we have 1, 2, 3, 4, 5 of them, plus 1, 2, 3, 4, 5 of them, plus 1, 2, 3, 4, plus 3, plus 2, and plus 1. And there is your answer. Again, let's add them up. Let's add them up. Where is my pointer? I cannot talk without a pointer. 1 plus 2 is 3. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. And 10 plus 10, 5 plus 5 is 10, is 20. The final answer is 20. Now, here's the million-dollar question. The million-dollar question is there a way to find the answer to this question without having to spend an hour and a half on it? And the answer, fortunately, is yes. So now I'm going to show you the quicker way, which is going to go like that. This question, for somebody who knows what's going on, this question should be done like that in 30 seconds, a minute if you're slow. No more than 30 seconds. Do you understand? Here's how it goes. We're going to do it on the top. So the key here is to understand that we don't have to enumerate all the diagonals. Nobody was asking us to make a list of it. They're simply asking us how many diagonals are there. So ask yourself, a diagonal of course has 2 points, for one point, starting point and the ending point. How many starting points can we have? How many starting points can we have for a diagonal? Well, obviously there are 8 choices. There are 8 choices because there are 8 vertices. A, B, C, D, E, F, G, H. I can start from anywhere. There are 8 choices. I can start my diagonal. Well, how many choices do I have to end my diagonal? That's the tricky part. We do not have 7 choices. Pay attention. Pay very close attention. We do not have 7 choices to finish our diagonals. We only have 5 choices to finish our diagonal because as I pointed out from the very beginning, when we start with point A, if your starting point is point A, then point B cannot be used as the ending point of the diagonal because that is the side of the octagon. Similarly, point H does not count. So there are 8 points altogether. This is the starting point. That leaves us with 7, and these 2 cannot be used because these constitute as the 2 sides of the octagon. So we have only 5 choices left. If I choose point A as a starting point, then we can have either C, D, E, F, or G. Only 5 choices. But that's 40. 8 times 5 is 40. We're getting the answer of 20. Why are we getting 40? We're getting 40 because the way we presented this work so far, this thing allows repetition. What we have here is something that will allow repetition. This is what we have here. This is called permutation. This is called permutation. In a question like this, what we need is a combination. In a combination, the repetition is not allowed. So when we have AB, there is no AB. When we have AC as a diagonal, we cannot list CA as another diagonal. But here, in this method, it is presented CA as a separate diagonal. Similarly, when we have FG, GF is also presented as another diagonal, which is why we have twice as many. So we have to take this whole total and divide it by 2, Because, why? Because each diagonal is counted twice. Each diagonal is counted twice. And when we do that, when we divide it by 2, and hence we disallow the repetition, it is no longer called permutation. What we have here is what is known as combination. What we have here is what is known as combination. Combination does not allow repetition. I'll give you a mnemonic device to remember it. This is the mnemonic device that I use. It's very simple. Just remember. Permutation permits repetitions. That's the mnemonic that I use. I tell myself permutation permits repetition, and therefore combination does not. Here we're looking for combination of 2 points, and combination of 2 points is exactly what it says. Once I have combined point A and B, I cannot go around saying that BA is another combination. Well, that's the combination. B and A. A and B is the same thing. It doesn't allow repetition. Combination does not allow repetition. Permutation permits repetition. Combination does not. What we needed here was combination. And that's all we need to do here. It should take no more than a few seconds. We just have to realize there are 8 starting points, 5 ending points, that's 40. Divide that by half, divided by 2, take half of that amount because we can't allow repetition. And that's it, we're done. 10 seconds, 15 seconds, 20, 30 at the most. That's it. And the problem should be done in a jiffy. You understand? I'll see you tomorrow, okay? Bye now.